Hi guys, today we are going to do two calculations. Okay, two types here. We are still on 1.5 and to write and construct balanced equations. Now I told you earlier we did the equations here is for redox, okay? Redox reactions. Today we balance on total number of atoms, all right? Right, so this is the first part. Okay, total number. I show you there are two types. There are two types of questions here, okay? When you don't give no numbers and with numbers. Okay, after you have a look, then I hope we can finish on time, and then so we perform calculations here, perform calculations using the mole concept. Now, mole concept here, you have three types, one with solids, which is the masses, solids here. So solids, we use this one, okay, number of moles equals to M, mass of solid, over AR, which is your elements. Number of moles for mass over the MR, which is your compounds. For gases, we use this equals to nRT. And for solutions, we use some formulas. I will go over that later. Okay, now quickly let's go to balance, construct balance equations. Right, now I'm going to show you the two types of questions that come out. Okay, the first one. Okay. 297. I'm sorry, 297. Okay. Now here you can see I've done scribble so many times. Okay. Here you can see the following equations, letters W, X, Y, and Z, all represent whole numbers. Okay. But when correctly balanced, which equation requires one of the letters W, X, Y, and or Z to be 5? Okay. So the key to get what, which is 5. So how to do such a thing? I got 4 examples here, right? So which is correct? That means one of them must be 5 here, okay? So now, so how do we do it? Now look at here. First, of course, now I'm going to use green pen. So I did a few times with it. Okay, now, okay, I copy this over here. Now, this on the left-hand side here are all your reagents, okay? Reagents, right? So here, like here, all are the reagents, okay? And the total number of atoms of all the elements must equal to the total number of all the atoms of all the elements in the compound. It's right here. So that's the whole idea. Okay. So now here's W moles combined with X moles to give it Y moles and Z moles, okay? So now for the first one, of course, now there you see there are 4 types of elements here: carbon, hydrogen, and oxygen, okay? So on the left-hand side, which is the reagents, okay? This is the reagents. All right, how many carbons are there? For 1 mole, there's 3 plus 1, so 4. 4 times W, 4W, okay, of carbon, yes, now. Okay. Now on the product side, this is the products. Okay. So for carbon dioxide, one mole is one atom of carbon, so Y atoms of carbon. Okay. Right. None here. So you can see here, I can say 4W equals to Y. Yes, now. Okay. So this is the first equation I get. Second one, of course, hydrogen. For 1 mole of the carboxylic acid, right? How many hydrogen are there? There's 7 here, plus 1 here, so it's 8, right? But there are 4 moles here, so there's W moles here, so 8W. Okay. On this side, only water has got hydrogen. So 1 mole has 2, so 2, isn't it? Right? So how many moles of hydrogen here is 2Z. Okay, so now I've got 8W equals to 2Z. So it's over here, 8W equals to 2Z. Okay, so equation 1, equation 2. Next one, oxygen. Here, for 1 mole, there are 2 oxygen. So W moles, 2 times W. Okay, right? Okay, now for here, for oxygen, 1 mole got 2 atoms. X moles, 2X. Okay, So total with 2W plus 2x. Okay, right? Total with 2W plus 2x on the reagent side. Now, how about the product side? One more carbon dioxide got 2. So y moles 2y. Okay, 2y here. And here, one more of water got one atom of oxygen, so got Z. So Z. So total of 2y plus Z. Okay, so is equals to 2y plus Z, which is here. 2y, sorry, 2w, 2w plus 2x equals to 2y plus Z. Okay, so 1, 2, 3. So now I want to substitute it so that I would be able to. Why is it not moving? Wait, sure. Okay, substitute. All right. Now I'm going to use equation 3 here, right? Equation 3 here. Okay, something. Okay, equation 3. So I put 2w here from here and 2x here. Okay. Now I'm going to use y, change the y here. Okay, the y here to w. So 2y, okay, so it's 2y is 4w. 4w. Okay, plus, okay, z. From here, 8w equals to 2z, all right? So z is equal to 4w, so it's 4w here. Got it? Okay, so here 8w plus 4w give you 12w. Okay, 12w. Okay, so now here you can see 2w plus 2x, 12w. So I bring the 2w over this side. So I get 2x equals to 10w's. So ratio 1x equals to 5w's. Okay, so x is equal to 5 when w equals to 1. Okay, so this is how you know, oh, x is equals to 5. So A is the answer. You can work out for all this by yourself, okay, and see how it works out. Okay, I don't have time to go through every one of them. So now this is, see, you have to find all sorts of ways that Cambridge asks you and figure out the skill to achieve the answer. Okay, next one, of course, is page 3, 4, 5. All right, 3, 4, 5. I know it's going to be difficult. Okay, 1 or 2 is like that. 3, 4, 5. Okay. Now here, I did scribble here already. Arsenic chloride AsCl3 reacts with sodium borohydride NaBH4. They give you this equation here. Okay. Now here they give you the values. This they will sort of use this to guide you. Same thing how I start. Okay. Same thing here. I copy this one down here. Okay. Okay. So for arsenic, P here. P is here, given P here. So I put one atom of P. Okay, because 1 here. Here don't have S here. Here got Z. So R. So the first equation is P equals to R. You can see here, all the P here equals to R. See now. So it will guide you, no? See? Okay. Right? Obviously. Chlorine. 1 mole of arsenic chloride got 3 chlorine. So P is 3P. Okay. So here don't have chlorine. Here got 2 sodium chloride. So it's 1 mole got 1 chlorine. So S moles got S chlorine. Here 1 mole of boron trichloride got 3 atoms. So T moles got 3T. Okay. So 3P is equals to 3S. So here 3P equals to S plus 3T. So second equation here. Okay. Now here's sodium. Right? Sodium here is Q. Because 1 mole got 1 mole, 1 atom of sodium ion, so it's Q. Okay, Q here. So sodium here, 1 mole of sodium chloride, it got 1, so it's S atoms of sodium here. Nothing else here, so Q equals to S. Very simple. And you can see, can eliminate Q and S. All right? See, they're all the same one. Q and S. See? They're very tricky, isn't it? Okay, so we are on the spot here. So what would determine it? Of course, is a T. So now we come to the important part. So boron. Okay, only found here. Sodium boron hydride. So 1 more boron hydride is 1 here. So here's Q. Right? So here we have same also 1 here. Okay? So 1 more boron trichloride is 1 more. So T. Okay? So Q equals to T. So which one here is Q equals to T? Q and T. Okay, which one? Easy thing. So 4 and 3 not same, this not same. Obviously, this one now. See now, easy now. So C is the answer. Easy? Okay. All we can do is substitute 1 by 1. It takes for years. All right. So try and see now. If you want to check it out, you can put the whole thing inside here and see now. You can check it out. I won't have time to go through this. You can go through yourself, okay? You can see it balance of 4S, 4AS, 12 chlorine, 12 chlorine here, okay? 3Na, 3Na here. I did it already. 3B, 3B here, okay? 12 hydrogen, hydrogen. So it's well balanced. So it's a C answer. Okay? Now, next one. I'm going a bit fast, but I need to cover all the things, okay? So it's 387, sorry. 387. Okay. 387. Okay. All right. Another one. Okay. Okay. Now, shall I? Okay, I do it for you. Okay. So you can actually know what to do. Okay. All right. Now here, when copper reacts with 50% solution of nitric acid, nitrogen monoxide is evolved and a blue solution results. Here's the question: copper plus nitric acid, because the oxidizing agent is this one. Okay, the copper nitrate plus blah blah blah. All right. Now, so again, now watch. Scale is involved. Okay. Watch here. So P for copper is for copper. So here's 1 atom here. So P moles is P atom. Okay. Here don't have, but this is the reagent. Okay. This is the reagent. A reagent, sorry. But the products only this one here. Copper nitrate, only 1 atom here, so R, so R. The first one is P equals to R. Now check. P and R, summa sama. Okay, so you cannot differentiate here. Okay. That's not. Okay, now next one. Okay. Hydrogen. 1 atom here for 1 mole, so Q moles Q. Okay, here also only water got. 1 mole water is 2 atoms, so S moles 2S. Okay, so Q equals to 2S. Okay, so you can check Q and S. Q and S. Okay, so Q is equal to 2S, 4 and 2, correct. 6 and 3, correct. 8 and 4, correct. 8 and 4, correct. So cannot again, so these two finish. Right, now next one here. Next one is N. Okay, so the answer is T is the one that will prove, isn't it? Yeah, okay. Now N. N is equal to N here. 1 mole of nitric acid got 1 atom here. So Q moles Q. Okay, so here got 2 nitrogen here. So for 1 mole of copper nitrate, there's 1. So 2. 2, I can't see. Very easy, isn't it? So it's 2R. Here, nitric oxide, monoxide, you got 1 here. So at T moles of T. So be Q equals to what? 2R plus T. That's not. Okay? All right. Now, okay. Now, here, if you can solve it, be great. Okay? You can put S here, R, but it's too hard. It's one shot. Okay, never mind. Last one, oxygen. Here is 3, 1 more is 3 atoms, so 3Q. Okay, 3Q. Here is oxygen, there are 3 of them. 1, 2, 3. So here, 6. 3 times 2 is 6 times R, 6R. Okay? Here, 1 mole is 1. So S moles is S. Here, 1 mole is 1. T moles is T. So it's all here. So it's 3Q equals to 6R plus S plus T. So I'll try to eliminate some of these things here. So I'm going to put substitute here to here. Okay, put Q inside here. So it's 3 times Q is 2R plus T, isn't it? Okay, equal to 6R. Put it up maybe. I don't know why it doesn't move. Oops. Oh, I know the pen is there. I see. This is playing up. Sorry about this. Ayo. Okay, here. Right. So we have here the mosquitoes buzzing around me. Okay, remember I put it on here. So 3Q. So Q, I put this value inside here. Okay, to this value here. Okay, so I times it out. I get 6R. 3 times 2, 3T. 3T. Okay, get 6R. Okay, this cancels out there. So get 2T equals to S. I want to find T, isn't it? So which T is equal to 2S? Huh? Sorry, which S is equal to 2T? S is 2T. So I cannot, this S equal to T. So I cannot. So I cannot, this one. Right? S equals to 2T, isn't it? S equals to 2T, isn't it? T is 2, so answer is D. By elimination, because it's all ideas on mathematics. Okay, so we are halfway there. Okay, now let's go to calculations of number of moles of solids. Okay. All right, you can. The idea is you need to go over. There's no simple way to do it. Okay, and to see the type of question that come out. So the more you do, the better. All right, now 2, 2, 2. Okay, now remember we are into calculation of masses. Okay, I'm starting with the masses really for solids only today because I have no time to do everything, right? Because you need to do more of these kind of questions. Okay, 2, 2, 2. Here, see I did here, so I don't have to worry about wrong. Okay, now. Use the data below is relevant to this question. 2.920 gram number. See how they 4 6 figures here. Okay, so you better do all 4 6 figures before you actually round up. Okay, so 2.920 grams of group 2 element X reacts with excess of chlorine to form 5.287. So again, 4 6 figures of a compound. Group 2 of course is XCl2. So now I write the equation down here. Okay. So why I wrote that here? Because 1 mole, that means 1 mole here reacts with 2 moles. Give 1 mole. Now this is called stoichiometry. Okay, stoichiometry. Okay, of the equation. Okay, that means tell you the number of moles. Right? Balance equation. You must say a balance equation. Balance. Right? So here. So 1 mole here give you. Now, of course, it's 1 mole of chlorine molecule, but 2 moles of chlorine atoms. So depend on how you write here is chlorine atoms. Okay, never mind. Well, this is the mass here. So mass mole ratio. This is the compounding. It's always mass moles and then ratio. Easiest to work with. Okay. So here, the element X, metal X, is right here, right? This is the compound. So this one minus this one here will give you the grams of chlorine atoms. Okay, this Cl. Okay. So divide to change the moles. Remember, number of moles equals to what? Mass over AR as now. Yep. So mass over AR. I don't know AR. Put X. Put P or A. Don't care. Okay. So 2.367 divided by your Cl atom. Okay, now 35.5. Okay. So remember, this is the number of moles. So number of moles of chlorine or number of moles of X is 2:1. Yeah. Remember? Okay. So you can find an X equal to this one here. All right. So for 87.6, what is the metal group 2? 87.6. 87 group 2. Okay. Strontium. Yeah. All right. Easy, isn't it? Okay. One done. Now next one, of course, is all heating. Heating of group 2 of nitrates. Okay. The first one. Okay. The first one. Let's look at the page 248. Okay. See, I'm doing all this to teach you the skills of how to solve this kind of question. Okay, all on calculations. Okay, now. Okay, right now here we are. Right, this is a data booklet is relevant and blah blah blah. Mass nitrate. Okay, will decompose when heated to give you a white solid. Okay, a mixture of gases. One of the gases released is the oxide of nitrogen X. So here they remember. Okay, you need to know the equation. Okay, M. I use red ink now. Easy to see. Form 4 you did before. Thermal decomposition. Nitrate. Okay. 2 gives you 3 things when you heat. Thermal decompose give you the oxide of the metal plus the brown gas NO2 plus oxygen, which will rekindle a glowing flame. You can balance yourself later is 2 here, 2 here, and 4 here, and 1 here. Because there's 4 nitrogen as well. Okay, 2 times 2, 4. Okay, and it's 1 here. You can balance yourself. So the stoichiometry is 1 mole is to 2 moles is to 4 moles is to 1 mole. Okay, right? So here's same thing again. Here the mass of this one here. How much is it? Mass is 7.4 grams. Right? Until no reaction. Now they ask you the mass here, the mass for this fellow here, because X is an oxide of nitrogen, not the solid. So please don't. Okay, the mass put question mark here. So remember the here. Sorry, 2 moles. I will put 1 more. I will put 1 more. 2 moles. 2 moles here. 2 moles give you 4 moles. 1 moles. Yeah. So here 2 moles is to 4 moles here. Okay. Sorry about. It's going too fast. Okay, I want to beat the time today. Okay, mass. So change it to number of moles. Okay, and it's equals to mass, which is 7.4 divided by, now the MR of this is. Now I've done it here. If you calculate everything here, right? Now remember, magnesium. Okay, magnesium is 24.3, and all this here it is equals to, I got it here is 148.3 now. Okay, right? So the number of moles, of magnesium, I put it down here, magnesium nitrate. Okay, is equals to this value. Now this value here is equals to 0.050. Okay, right? Moles. Now remember, number of moles of this is equal to 4 times 1. Yeah. So number of moles of magnesium nitrate and okay, over number of moles of NO2 is equal to 2 over 4. Okay, right now, right? So 2 over 4. Right? 2 moles give you, now you can check, okay, 2 moles here. 2 times 2 is 4, isn't it? 4. So here must be 4, isn't it? Yes, no. Okay, you can, if you like, 2 times 2, 4. 4 times 3 is how much? 4 times 3 is 12. Okay, 12. So now here's how much? Here's oxygen is 2 times 2, 2, and 8, 10, 12, isn't it? Use 1 here, okay? So it's equals to 1 over 2, right? Okay, so now here the number of moles of this one is what? 0.05. All right, so this over 2, so bring up here, so times 2 equals to number of moles of what? Of your NO2, right? So number of moles of NO2 is equals to 0.1 mole. So now moles is equals to mass over MR, okay? So 0.1 equals to mass. What's the MR of NO2? I got it down here. NO2 is 14 plus 32. 14 plus 32 is how much? 46. It's 46. Okay, 46. So M is equals to 4.6. Okay? Can? All right. Okay, next one. Okay, still on heating of nitrates. 296. Okay, 296. We do a couple, then you figure out the rest yourself. Okay, right? Now here it comes in a different way. That's all. Okay, 15. Use a data booklet is relevant to this question. 5.00 grams sample of anhydrous group 2, say nitrate, loses 3.29 grams in mass when heated strongly. So which metal is it? Now here they tell you the loss in mass, which means the remaining one, of course, is the oxide of the metals in. So same idea lah. All right. So you can put down here M. Don't know the thing, put MnO3 2. Okay, I'm teaching you a skill. Okay, when you hit the fella, get what? MO plus NO2 plus O2. Remember, group 2 will always be 2 in front here. You can balance yourself. 2 here, and it'll be 4 here, and it'll be 1 here. So the ratio with 2 moles is to 2 moles is to 4 moles is to 1 mole. Is that clear? Okay. So now here the mass moles ratio is, yes, mass is equal to how much? 5.00 grams here. Loses so many grams, that means the total mass here, it lost 3.29 grams. Come out, because gas in it. So what's remaining here is 5.00 minus 3.29. So what did I find out? I found out this is equals to 1.71 grams. Okay. Yeah. So same thing here. The number of moles is the key to solving the whole problem. Because number of moles equals, right? Number of moles of your magnesium nitrate is equals to the number of moles of, sorry, not magnesium, M. Okay, I thought okay, MO. So can you find it? Of course you can. Let, of course here say like just now. Let the AR of M be equals to X or M, or let's say X. Okay, so X. So here will be, now remember the MR is equals to, right, X plus 2 times what? Nitrogen is 14 plus 3 times 16. Yes, now. Okay, so it's equals to X plus, I work it out here, the whole thing is 124. Okay, all right, okay. So here, now this is on this side. Now on this side here, right, the number of moles is equals to 5 over X plus 124. Yeah. Here the number of moles of MO is equals to 1 over 771 over 71 over M plus this is MR of 60. Okay. Okay. So these two are equal, isn't it? Yes. So you get what? You get here 5 over X plus 124 equals to 1.71 over M plus 16 or X plus 16. Ix plus 16. Okay, so for X now, you don't go back to form 1. Okay, X you find out is equals to 40.1. Of course, it's calcium. Can? Can? Easy peasy. Okay, now next one. I'm going a bit fast, okay? I hope you can catch up. I want to finish. How many more? 1, 2 more. Two more. Okay, 3 more. That's not here. Okay, I think we will finish before for 1 hour. To the first time. I'm sick of this already. Okay. 2, 3, 2. What is this? 3, 2. Why it's not moving? Okay, I cannot hold the pen. 2, 2, 3, 2. Okay, now this one here. So different things, different ways. Okay, put bigger. All right. So, okay. Can you see? Okay. So tanzanite, not Tarzan, is used as a gemstone in jewelry. It is hydrated calcium aluminum silicate, a mineral with the chemical formula, blah, blah, blah. Right? Now I'm going to write it down here. Ca 2 Alx silicate Y O is 12 OH funny one 6.5 funny as well H2O. Okay, the MR is this. Okay, they give a composition. Now this of course find empirical formulas, you know. Okay, I just want to show you how it's being done. So remember, mole mass moles in ratio. Now they give X and Y here. Okay, now all these numbers is telltale, you see. So mole is percentage, so we take 100%, right? 100% is equals to 100 grams. So calcium is how many grams? So it's 14.0 grams. 0.4. Oh, okay, 4. Aluminum, how many grams? 14.17. Okay. Silicon, how many grams? 14.75. Oxygen, total of all this oxygen is how many grams? Is 54.59. And hydrogen is oxygen, okay? Total hydrogen is how much? 2.45 grams. Okay, change to moles. 14.04 divided by 40. All right, this one is, I just write down here. You go back and check yourself, okay? 14.17. Aluminum is 27. Silicon 14.75 over silicon is 28.1. Oxygen 54.59 over 16, and hydrogen is 2.45 over 1. So the ratio you found out to be, the amount here, the amount first, okay? The amount is 0.351. This is 0.525. This is 0.525. This is 3.14. This is 2.45. To make it faster. So to find the ratio, take the smallest number, divide all by the smallest number, which is 0.351. 0.351 over 0.351. You go back and do don't go and like, it's correct, it's correct. Go and count it yourself. 0.351. Okay? So here's 1 is to 1.5 is to 1.5 is to 9.7 is to 7. Okay? 0.5 times 2. So it's 2 here is to 3 here is to 3 here is 2 times 2 how much? Times 2, 14, carry on to 18, 19.4. It's 14, isn't it? Okay? Right? You can do it yourself. Now, obviously, which is correct? X and Y. Okay? X is here, Y is here. So it's 3 is a 3. Actually, you can calculate out, for example, there are 19 here, okay? See, oxygen is 12, right? Plus 1 is 13. 6.5 is 1302. Okay? 1302. Right? Okay, now. So, of course, 6.5. So, plus 6.5 is 19.5, isn't it? So, it's 19.4, isn't it? Hydrogen. Here's 1 here, hydrogen. Okay, 1 here. Right, 6.5 is 12, 13 over 2 times 2. So it's 13, 1 plus 13, 14. Okay, right, very good. Now, 20 more minutes, let's do the next one. Okay. Now, this one is a reduction with using organic substance. Okay, so I give you the various kinds of things here which involve mole ratio and solids. Okay, and grams, mass basically. 302. I don't know why this is 302. I don't know why it's not moving. This fellow today is playing out with me. 302. Okay, I don't know why it's wrong. It's too hot, I know. See. Let's try it. Go up and down, okay? Okay. See, something that's moving, and this is not moving. Screen sharing. Guys, I don't know what is happening with this computer. See? Ah, now it's moving. Okay, 302. Got a page. I got nothing here. Wait, I'm sorry, but I'm not very good with this. For one. But remember, you really need to work on go and do again until you get the idea. Okay, coming up here. Okay, right, you have to practice, and not only practice, perfect practice. Okay, go through all these questions here, so that you when it comes out, you know how the style, how it actually comes out, right? So I will use this this app here because otherwise I cannot use the Huion, you see. 302, which is here. Nothing. Okay. Here. Oh, thank you, Lord. Okay. All right. Now, step by step. Okay. Compound A is an organic. Compound A is organic compound which contains carbon, hydrogen, oxygen. Okay. Now, see grams given. That's why I choose this one here. When 0.24 grams of a vapor A is passed through a large amount of heated copper to oxide, the organic compound A is completely oxidized to carbon dioxide and water, and copper is only product left. All right. Okay. So you can see, like if you want to talk about it, CXHY, okay, OZ, whatever, plus CuO. Okay. They'll give you copper plus carbon dioxide and water. You cannot balance the equation because you don't know the formula. Say, never mind, this is very simple one. Right? Right? The products collected is found to be, so here is the mass is how much? 0.352 grams. And water is 0.144 grams. Okay. Okay, they lead you step by step. Calculate the mass of carbon dioxide, the mass of carbon present in the CO2. Very simple. Carbon dioxide is 12 plus 2 times 16. It is 12 and 32. So 44 grams. So in 44 grams of carbon dioxide, how many grams of carbon are found? 12 grams. Yeah. So 0.352 grams contain how much? 12 over 44 times 0.352. Okay, you can see here the answer is given here. Okay, okay. All right, see now, 12, so it's 0.096, okay, 96. 0.096 grams. Okay, calculate, use this to calculate number of moles of carbon atoms present. Okay, number of moles. So number of moles equals to what? Mass over AR. Yeah. So the mass is 0.096 over AR is 12. Is equals to, you can see from here again, the answer 0.008, okay now? Okay, 0.008 moles of carbon. All right, now for hydrogen, again, you get stuck. Hydrogen, now mind now, okay, you can do this, okay? Number of moles of hydrogen. Now remember, hydrogen here is H2O. So 2 times 1 plus 16, why not? This was 18. Okay, right? So here 18 grams of water contains 2 grams of hydrogen. So 1.44 grams contain 2 over 18 times 1.44. You can see the answer here. Okay, 144, right? Right? 18, where is it? Okay, yeah. 0.016. Okay? 0.016. Okay, grams. Now the next time they ask you what's change the number of moles. So the number of moles of hydrogen will equals to the mass over the AR. Equal to 0.016 over 1 is 0.016. Okay? Right? So then of course this is the moles for carbon. It's the moles for hydrogen. Okay? I hope it's recording, man. Otherwise, they didn't record. Spoiled already. All right, now now you can see the answer here. See now. Okay, so the moles this one here, carbon. So you can, actually later you can go and do, okay. You can calculate the number of moles of hydrogen, oxygen. Okay, quite easy. Okay, there's something is spoiled here. Right, the ratio. Okay, so this is equals to 1 to 1. Okay, which gives this the empirical formula. Okay, all right. If we cannot do it, then I think it's spoiled. Never mind. Okay, all right. See here. Okay, so empirical formula. Okay. Okay, now last one before the fellow go quiet. 318. Okay, remember. Okay, now this is calculation form 5 work. Okay, zinc is an essential trace element which is necessary for healthy growth in animals and so forth. Okay, simple experiment determine the value of X in the formula Zn. Here's X here, X moles, okay, and heat. Now remember, this is very important. This is the key. Remember here it means remember this is 1 mole here. Always remember. Okay, I'm going to put this here. Okay, this is 1 mole here. So 1 mole of the whole thing gives you 1 mole here, and how many moles? X moles. Okay, now this is the key. Or we say 1 is to X. Okay, now, and then so forth. Now, of course, use a hydrated zinc and weight empty bottle. We weigh and so forth, heat until it's normal. Okay, the mass of empty bottle is 74.25. Mass of a hydrated salt, that means this minus this, you get the mass of the hydrated, the mass of, okay, hydrated. So remember, so here, if I want to put down here the mass, if I want to put on top, okay, on top here. So the mass of this one here, this one here, right, is this minus this one. Actually, I get is 3.72, okay? And this one, of course, minus this one here, give the mass of the anhydrous, which is 2.09. Okay, I'm doing a bit fast here. Okay, so you can find the mass of water. mass of water is, of course, this minus from here. You will get what? 163. Now, all you got to do is, what? Find the number of moles of which one? Of course, this one is it. You can't find the moles, number of moles is not here because you don't know X, you don't know X. So this one you can find. So the number of moles, right? This one is anhydrous. Okay? So number of moles of anhydrous, okay? We'll do it here, just in case. Number of moles of anhydrous is the mass over MR. So the mass is 2.6, sorry, 09, not 69, 09. Over now, the MR of this one is very simple. All right, is 60, zinc is 65.4 plus 32 plus 4 times 16. So you can find is equals to, let's see, I actually try too fast. Okay, here and here, here, okay, here is 2.09. Okay, now water. To find the number of moles of water, I can find, right? Number of moles of water is equals to mass over MR again. What's the mass? 1.36, sorry. Okay, I'm trying to hurry, plus 18. Okay, which is equals to here. So it is over 2.0. What am I doing? Okay, the whole thing is 161.4. Here is 1.63 over 18. Okay, right now if you solve it out here, this is equals to 0.013. This is 0.091. So divide by the smallest number. Okay, so here divide by 0. So ratio now 0.13, and this is 0.013. This 1 is to how much? This is 7 here. So x is equal to 7. Okay. Now this is a favorite question for your practical. Okay. So you can find x here. All right. Now I finished 10 minutes before time. And I'm sorry I hurry here, and there's so much messed up now. Go over again. Try to figure out, do it again until you get the idea. Okay? All right. So thank you, and see you soon. Okay? Bye bye. I want to stop. How to stop for the? Okay, here. Stop.